Good day, ladies and gentlemen. This is Sarel van Grenen, aka Mr. VG, and this is such a beautiful, beautiful, beautiful day. And today is an amazing day specifically to work with Euclidean geometry. So when we look at Euclidean geometry, Euclidean geometry is that one section where either you go through your theorems and you've studied your theorems, or you're not going to get how to do these kind of problems, because this specific video is where we are going into the part 2 where life becomes more interesting, because we are going to go away from working with actual values, so 30 degrees, 40 degrees. We're going to work more with what we call geometrical riders. We are going to ask you prove something without you actually knowing what the values are. So when I look at this is now the question 10 from the GDE, the Gauteng Department of Education, 2020 paper, the November exam. So I'm going to ask you, hit the pause button, try it yourself, and then you come back and let's look at doing the sum together. Now, when I look at this, my first instruction to you would be, don't rush the sum. Okay, don't rush the sum, meaning don't just go to the answer and try and figure the answer out. No. First, mine. So dig into the information without regard to where you are going. So when I look at this, it says that O is the center of the circle. So by looking at the center of the circle, I know that I've got radii. So I have OW, OY, and OZ all being equal to one another. Okay? It's maybe better for me if I don't use single lines again. Let me use double lines. Okay? Let me just get the right color. So let me use double lines. Okay, so just so you don't confuse it with the single lines that are also equal. Once I have equal sides, I automatically look for isosceles triangles. So in the triangle OYZ, I have that Y2 is equal to Z1 and 2. Looking at the other triangle OWZ, I have angle W equal to Z3. Okay? Those are my isosceles triangles. It says now also that it is a center. So the moment I read center, I know there are 3 theorems in grade 11 I need to look out for. Theorem 1, 2, and 3. So let's start with theorem 1. They do say that U is the midpoint. So in other words, U2 is 90 degrees. Simple and straightforward, okay? Next up, do I have an angle at the center? Yes, I do. O1 is twice as large as W. But also, this is one you must kind of look out for because they love to ask it, is that in a triangle or in these kind of sums where we go to the side, okay, because that's also one where if I look at going from O1, I can actually bring it together here by X, okay? So in other words, if I bring it together like that, I'm going to say that O1 is also twice as large as the angle X. Now that's going to help us a bit later on, but don't worry about that now. Remember, we are not worried about where we're going. We are just indicating it on the sketch. Let's have a look. Is there anything else we need? What about theorem 3? I've got a diameter, YOW, so therefore the whole angle Z is 90 degrees. Now I love to think about this because 90 degrees points me toward Pythagoras, towards SOHCAHTOA, although really use SOHCAHTOA much in Euclidean geometry, but it doesn't stop me from actually having to do it. Okay, it's very possible for us to actually do it. Let's now have a look at cyclic quadrilaterals. That's the one thing you've got to always remember, ladies and gents. You can assume a cyclic quad. Now, my cyclic quad, there's a bow tie there with y, x, w, z, which means that first of all, w is equal to z, which we know because they're both a half of O1. But secondly, y1 is actually equal to not z3, but let me just make it a bit clearer, that whole one there. So z2 and 3 together. Okay? And look what I do on the side. I write next to the dot, it's theorem 4. So if I need it later on, I know where it comes from. Okay? So let's have a look at question 10.1. It says there, first of all, express O1, angle O1 in terms of theta. But that's simple, because O1 is 2 times pi x, which is 2 times theta. Angle at center is 2 times angle at circumference. Then when we've got W, how does W relate to x? Or to theta, I mean. Okay, I'm so used to solving x that I want to bring x in here. So how does it relate? Well, W is actually equal to x because of angles in the same segment. So in other words, W is also theta. Last but not least, we've got Y2. But please, ladies and gentlemen, now we kind of need to go and say, okay, but how does Y2 relate to the rest of what we've done so far? Well, Y2 in a triangle, in this triangle here at the top, if I can get Z, which I can actually do, okay, then I can get Y2 with interior angles of a triangle. So I'm first of all going to say that angle Z is 90 degrees because of angles in a semicircle. So Y2 is equal to 180 minus 90, but remember that 90 comes from being Z, minus W. And why is that? Because of interior angles of a triangle. If I simplify this, I'm going to get 90 degrees minus theta. And there I've answered my questions. Okay? I hope you're all right with this, ladies and gents. But this is a very, very important way of doing geometry. Okay? I know it takes time initially to analyze all of the theorems. But look, the video is 8.5 minutes long. And about the first minute and a half was just an introduction. So we've spent 7 minutes analyzing it, as well as answering questions 10.1 to 10.1.2 and 10.1.3. So if you've analyzed it proper, in a good way, looking at all your different theorems, then your answering of the questions are going to be much, much simpler. So let's look at question 10.2. But for us to look at question 10.2, it says there, determine YZ in terms of R, which is the radius of the circle. So let's just first put in what we've got, okay? I know that there are 90 degrees, and I know that OY is also equal to R, okay? I've got OZ, but I'm not going to worry about OZ now. Because in triangle YWZ, I have that Z is 90 degrees. Remember, we've proven it already. Okay, we need that. Because I can now start to think about Pythagoras. So WY squared is equal to WZ squared plus YZ squared. And this is because of Pythagoras. Let's not forget our reason. When we have a look now going forward, okay, remember the question is, I want YZ in terms of R. Now I know that WY is equal to 2R. That I know because it is the length of 2 radii. So I can put that in on the sketch. Next up, I know that WZ is 2 times by YZ. Why is that? Because remember, these 3 sides are equal. So if I put this in, I'm going to have an equation that looks like that. So remember that WY is 2 radii, and then WZ is 2 times by YZ. Okay, simply by the fact of being equal lines. Now, at this moment of time, ladies and gents, I want you to understand, I'm not just randomly throwing in things. I'm looking at where I want to go. I only want YZs and R's in my sum. I don't want anything else. That's why I'm manipulating it like that. So all I'm going to do now is I'm going to square out my brackets. So that is 4YZ squared plus YZ squared, and that is equal to 4R squared. On the right-hand side, I've got 5YZ squared, and I'm trying to isolate YZ. So in other words, now I'm taking the square root on both sides, and at the top, the root of 4R squared is just 2R over the root of 5. As easy and as simple as that. Now I'm lying. There's nothing easy and simple about this. This is an interesting sum. I love it. But it isn't impossible. It is not impossible if you look at how I am thinking when I'm answering this question. So let's have a look at the last question. So I've put in 10.3, I've placed what they are asking me on the sketch. So it says there, hence or otherwise, calculate the value of UV if it is further given that OU is equal to 2 centimeters and UW is equal to 4. So I chose to do the or otherwise, okay? There's absolutely nothing that forces me to use what they are asking me to use, okay? So what I'm going to do is I'm going to use Pythagoras, again with U2 being 90 degrees, line from center bisecting the chord, and this leads me towards Pythagoras, because what I'm trying to do is I'm trying to calculate R, okay? So if I get R squared, the answer is 20. Okay, 2 squared plus 4 squared. So R is equal to the root of 20. And last but not least, UV is then, take that to explain what I did here, remember that R is actually equal to OU plus UV. And now that R is root of 20, and OU is 2, to get UV alone, I'm just going to subtract 2 on both sides. And there you've got the value for UV. As simple and as easy as that. Okay? Now there are other ways of doing it. Okay? And I am very much suspecting that there is another way of doing it because there's 2 marks. Okay? And the alternative, ladies and gentlemen, and you'll see that I pasted in there for YZ, is that I could simply replace YZ with 4 because it's the same as WU. And then I solve for R and I get exactly the same answer for R as being root of 20. That is what I love about mathematics, ladies and gentlemen. There are many, many different ways of doing it. And if I look at the question, it says hence or otherwise. Whenever I see that, an easy way is looking at what you did previously and asking yourself, but how are you going to solve the rest? There we go, ladies and gentlemen. I hope you enjoyed this. I hope that you are now fully, engaged with Euclidean geometry, and especially with riders like the ones we had earlier where we're writing in terms of theta or proving things. Okay? So, this is me, Mr. VG, signing out. Please tune into the next video, which is the last video of this grade 11 exam preparation conference. I'm going to look at another absolutely gorgeous Euclidean geometry sum. So enjoy your day, behave yourself, and look after yourself. Keep well. Bye-bye.